Need to start now, huh? Hello, everybody. Recording in progress has been declared. So we're going to start now. I hope you can see my screen. I am sharing my screen. This little presentation is about framing and strategy, which are two things not much attention is paid to, I am sad to say, in the world of testing education. So I will try to redress that here and now today. So let's get started with that. First, let me talk about test strategy. This is what I mean by test strategy. A lot of companies have a different meaning of strategy. A lot of companies think that strategy is the overarching approach to software testing that your whole company follows. I call that methodology, not strategy. I'm following a definition of strategy which comes out of the military tradition, what military theorists call strategy. And I've adapted that to testing. So methodology for me is generic. Methodology applies to any project, but strategy is specific to a project and a product. That is to say, a good strategy will be tailored to each product and project. If you find yourself using the same test strategy across projects, then I think you can improve that strategy by making it more specific. Test strategy in the rapid software testing world is, which is my methodology, is the set of ideas that guide the test design for a specific product. Now, when I say set of ideas, notice that I don't say document. You can have a test strategy that is not documented. In fact, we all have test strategies that aren't documented. If you do good testing, if you do testing in a systematic way, whether you have written it down or not, I would argue you must have a set of ideas guiding you that are in principle able to be talked about. When I say guide, I don't necessarily mean completely determine, because there are many factors that cause you to test in one way or another, not just your strategy. In a sense, your strategy is your intention for what you're going to do, but many practical things could get in the way in any particular moment that draw you away from your strategy. You might set out to do something on a particular day, but the circumstances are such that you are forced to deal with some emergency, or you don't have the build available, and so your strategy is unfulfilled or needs to be modified in that particular moment. When I say test design, I'm talking about the choices of what tests to design, the particular choices that represent the design of those tests. That is to say, the arrangement of the elements and factors and all the choices you make that define that test. Those choices are all indicative of design. If you create a test and later you choose to perform that test again in a particular later time and place, that also is a test design decision. So I'm using test design in a rather expansive way. I'm basically trying to say that strategy, test strategy, is whatever those guiding our ideas are that control the testing itself, not any of the logistics around testing, but the actual substance of the testing. And then strategy is specific to a product, as I was saying. So that's what I mean by strategy, by test strategy. But I've also referred to something called test framing. What do I mean by that? Test framing is related to test strategy. Test framing is the ability to explain for anything you do as a tester what it is and why it matters. So no matter what you are doing as a tester, if I stop you at that moment and say, what are you doing right now? If you say, I don't know, that's poor test framing. If I say, why are you doing that? And you say, I don't know, that's poor test framing. Or if you say, I'm doing it because my boss told me to do it, that also is poor test framing. Maybe there's some good reason that your boss told you to do this. But in that case, I'm going to have to go ask your boss because I'm not getting anything out of you. Test framing connects the business ultimately and the needs of the business to everything we do as testers. Now, Michael wrote a blog post about this. Here's a little QR code to go see that if you want to. It's a nice little bit of text that he wrote, like 11 years ago, right after I coined the term test framing. I think I didn't write a blog post about it. I think he is the first one to do that. If you have unframed testing, then that's just another way of saying, I don't know what's going on. I don't know what I'm doing. I don't know why I'm doing it. So you're just floating in a way that's disconnected from the business that has hired you to do testing. So test strategy and framing, they work together. And here's a stack of 4 things. Okay, you got your test activities. That's what you are doing to test. Your test strategy or ideas that are guiding the test design aspects of those test activities. You've got your project, which you are testing for. The project is serving the business. Well, these things are there. Fine. So what, you say? So framing binds them together. Framing is the logic that binds them together, not just the things themselves, but the connective tissue, the reasoning, the logic. Why are we doing these test activities? Because the test strategy wants us to. Okay, how does the test strategy serve the project? How does the project serve the business? I need to know all these things if I'm going to do good framing, because with good framing, anything I'm doing, I can say, this is good for the business. That's why you should want me to do it. Oh, grand bosses of mine. You can do good looking framing, but with a bad story, with a bad strategy. So I have intentionally put this in a font that's difficult for you to read. I have put around it statements of disparaging nature. I do not want you to do this, but this is legitimate framing. It's a bad idea, I think. So it's also a very popular idea, especially among people who don't know much about testing, don't study testing, don't really care much about testing, is they read a user story or they have a requirement and they say, let's do a test for that. And then they come up with some simplistic test, some sanity test, we'll just see if it works one time. And then a lot of times these days, they try to automate it, right? So then you have all your tests. Maybe you've written them down in detail. Maybe you've automated them. And then the idea is, do all the tests pass? Well, if they all pass, then people who don't know any better, think, I have just proven that the product works, which they haven't done, but they think they have. And then they think that leads them to business success. So lots of people in our industry just want to see a whole report full of green check marks that just say pass, 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 pass. And they want to see a lot of test cases maybe, so they get the impression that lots of testing is happening. But this is really covering up the testing that's really happening. You can tell this story. It seems like you're connecting it to business success, but a wise listener will realize you haven't said anything about the quality of your testing by just telling me that you have one test or even 100 tests per requirement or per user story. I would have to ask the question, what is the test? What exactly are you doing to test? Because you might be doing terrible things to test that aren't going to find any bugs. You might be doing great things to test. I don't know. This is a story that seems to connect what you're doing to the business, and yet I'm not getting any information about the nature of that connection. One way to see why is this is entirely generic. This could be true for anything you can possibly test. So that's a clue right there. If you've got a strategy that's completely generic, it's probably not a good strategy. So this is very common. Please don't do it. Instead, a clue to doing this better is to think about risk and focus on risk. So let's take this and let's say we have a risk-based test strategy, and the connections between test activities and the risk-based test strategy is that the risk-based test strategy is directing us to test for specific risks or risk areas. And then we discover and we analyze those risks for the project. The project then minimizes and manages this, which is not a testing thing. So when we're framing our testing, we may say, I'm doing this testing so I can discover about these kinds of product risks, these kinds of failures, in other words, that might be in my product. And I've discovered the following possible problems. I don't fix those problems, the project does. But the reason why I'm doing all this is so that everyone else on the project who's not a tester, so that they can minimize or manage risk. It's important to understand that testing itself does not mitigate risk. Testing itself does not minimize or manage risk. If you ever minimize or manage risk as a tester, you are not behaving as a tester in that moment. As I just put out on LinkedIn, a similar situation crops up for journalists. If you are writing a story about a little cat stuck in a tree, you are a journalist. But if you save the cat in the tree, that is not an act of journalism. That's an act of helping cats, whatever the word is for someone who helps cats for a living. That's what that is.
That would be a felicitator.
Oh, a felicitator. Right. You have done cat felicitation, which is cat facilitation. Okay. I'm not gonna do any more wordplay on that. Okay. Too early in the morning for me for that. Now let's zoom in on risk. Let's put that in a frame. What's going on with risk? Risk-based testing involves a cycle. The cycle looks like this: conjecture, focus, reality. Conjecture, focus, reality. What are we conjecturing about? We are conjecturing about possible problems in the product. Where might those bugs live? What kinds of bugs might there be? And then we focus our testing efforts on those things that we think might go wrong. And then we see what really does go wrong. And when we see what we really actually find, that causes us to refine our sense of risk, and then we can do maybe even better testing. So if you're doing regression testing because some change has been made, and you say, well, if you're going to change this part of the product, maybe you've put a bug into that part of the product. So you focus on that part of the product that's been changed. And sure enough, you do find a problem that has been introduced by the developers. What is that? What happens to you? You feel like you want to do even more testing. Maybe there's even more bugs in there. So that's the risk-based testing focusing loop. So I use a narrative model of testing, and because Michael has to go before the end of my little presentation here, and I want him to see some stuff that I put at the end, I'm going to come back to this and go through this narrative model a little bit later. I'm going to walk you through the whole thing. This model is a pattern that I use that helps me tell the testing story and helps me put my test strategy to work. Okay, but I'll come back to that. A key skill for strategizing and framing is the skill of summarizing. We need to be able to summarize the technologies that we are testing. If you want to come up with a strategy, and if you want to frame your testing using that strategy, you got to be able to take really complex products and boil them down. So there's lots of different ways that we could talk about this. But I've come up with a set of diagrams, because one way to do it is to make little pictures. So I thought I'd share some of my pictures with you to give you some ideas about this. I do a lot of visual strategizing, you might say. Let's start with something really simple. And throughout this, I hope you're able to read my screen handwriting. It is not always easy to read, but I thought it creates a certain whiteboard earthiness to the presentation. So that's what I'm gonna show you. Okay, one way that we can summarize a product is very, very simple. I'm sure you've done this many times. Just break the product up into a bunch of areas and say, this product has 5 basic areas. I am then going to test each one of the areas. So for each one of these diagrams, I'm going to give you in black the summary of the product, and then in red, I'm going to put out what my strategic response to that summary is. So if I'm thinking of a product in terms of it consists of X number of areas, then I'm going to sample from each of those areas when I test. I might have a big sample, I might have a very small sample, but as soon as I summarize a product as consisting of, say, 6 areas, as we see here, then I know that I have at least 6 acts of testing that I am going to do, one on each of those areas, at the very least. Another way I can summarize a product, perhaps the very same product, is I can do this. This divides the product into 2 kinds of features: primary features and contributing features. A primary feature is defined as a feature that the product cannot do without. If a primary feature fails, the entire product is useless. Here's an example. If you were testing a word processor, like Microsoft Word, and the word processor could not save a file, you would always lose your work as soon as you left the program. We would not call that a functioning word processor. If you couldn't type into it, we would say this is a completely useless piece of junk. You can't do anything with this. But Microsoft Word has lots of features that are not primary. For instance, it has a feature of counting words in paragraphs or in documents. If that feature were to fail, you would still have a functioning word processor. It just wouldn't be quite as good. So that's a contributing feature. So one way to summarize a product is to say, which are the features that are really core, that are really fundamental? And I'm going to put more testing effort into the primary features and less effort into the contributing features. Notice that I can take the first one that I showed you, the areas, I can put that right on top of the second one. They both can work together. And you'll see with these diagrams, there's ways to put these diagrams together. You can have a product which involves more than one of these summarized patterns. Okay, here's another one. Old to new. Let's say you have an old product and your project is to replace the old product with a new product that does the same thing. It's completely redesigned from the ground up, but it does the same thing. It produces the same output. Well, if that's the case, I immediately think about parallel testing. I want to run the old system and the new system at the same time and compare their outputs whenever I give it the same input. Well, sometimes that's not going to work because there's huge differences between the output formats, but this is one of the strategic ideas that I immediately think about. Here's a different take on that. What if the old part of the product is not going away? You're not replacing the old with the new. You're adding something new onto the old. What are you going to do then? Well, I'd draw out something like this. I would say that for the new stuff, well, I'm just going to do regular new testing on that. But for the old stuff, I have to do specialized regression testing. I've got to make sure that the new thing bolted onto the old thing doesn't cause the old thing to fail. Maybe I have old regression automation and I'll use that. Maybe I won't be able to use that because the new stuff disrupts that. So this is my major concern with both of those. There's a completely different way to summarize a product. Maybe you have a product that involves a really complicated, hard to understand algorithm, and it produces incredible output. You know what I'm talking about. AI. AI is like this. It's obscure and impenetrable, but it can recognize human faces, for instance. Okay, so now we have a problem because you're testing a system that can recognize human faces and tell them apart from cat faces. How do you test something like that? It's not easy. But what we're going to have to do is develop a test data library. That's very important in these kinds of situations. We're going to have to talk to the developers and learn as much as we can about how this algorithm works and what might cause this algorithm to fail. We may need to research similar products. We need to find a good test oracle for the output. How do we know that the product actually did the correct thing, because this output it's producing might be very complicated. Now, it might be very simple. It might be as simple as saying, yes, that face is your face, tester, and the system recognizes your face. And that's an easy oracle because you know if something is or is not your own face. But it's not so easy when you have thousands of examples and you have to pour over each one. So in systems like that, we need to put a potentially considerable amount of development effort into our test data libraries and our testing systems. What do you think this is talking about? I hope you can guess from the pensive look that I designed into the user. What if you have a user, you have a new user, and the new user is trying to learn the system that you are developing, and you're worried that it's going to be difficult for this user to learn the system. So what do you do then as a tester? That calls for usability testing and documentation review. And if there is a social community around your product, then you probably are going to enlist the community to help you construct tutorials, to help you with ideas about usability, to help you review the documentation. As soon as there's a community involved, I can see that community almost as part of the product. If you've ever used Google, then you've seen a product that can be summarized like this. If you were to test Google, you have a big problem because Google has just crawled countless millions of websites. Well, how do you know when you do a search that you're getting the right set of websites? It's very hard to know because you don't know the contents of this vast data lake. So what I need in this situation is I probably need a subset, a controlled data set that I can test with. And I need that in a sandbox that I control. And that sandbox may be like a mini Google that has only a few gigabytes of data in it. And maybe I can test with that. I can also test with Google's production data, but in that case, since I don't know what the data is, I have to fall back and do perhaps statistical testing with what I will call a sparse oracle. A sparse oracle is one where you don't know whether the whole output is correct, but you know if some of it is okay. Maybe you have certain statistical expectations about the number of hits that you'll get for different kinds of things. And you can see over time how that changes. I would use those methods probably. And of course, I would test via an API if I'm trying to understand if this vast data lake is any good. I'm not going to be testing experientially through the GUI interface. Would be a very inefficient way to do that. I would do some testing experientially, but I would be mainly focused on API level testing and trying to do 100,000 searches of this vast data lake. All of us have tested systems like this because web-based systems are like this. You have an app, you have a platform on which the app runs. Maybe that platform is Chrome. Maybe it's Firefox. Maybe we could talk about the platform as Windows or Linux. But we have some kind of platform elements. The platform elements are defined as those elements we do not control with our project. We didn't write the platform, but we have to cope with the platform. So there we have compatibility testing, where we're going to switch out the platform and try testing the app with different elements. Now, whenever you have this, you have a test scoping problem as well, because when we test the app, we have to be aware of what aspects of the application behavior actually belong to the platform and which are actually part of our code. Because otherwise, you're testing your web app in Chrome and you see some sort of misbehavior, and it turns out, well, that's just how Chrome works. It's not a bug. It's out of scope for our product. And of course, anytime you see data, we can ask the question, well, what data should we be testing with? Because depending on the data, we may see failures or we may not see failures. So we still have to create a data library. So I hope you see a pattern in what I'm doing here. I make little simplified diagrams representing particular aspects of the product. These are fairly generic diagrams, but they have a specific relationship to any given specific product that you apply them to. And then you can, based on the diagrams, come up with general ideas, but those general ideas still need to be applied specifically to your specific product. And that's the process of creating a specific test strategy and, of course, specific tests. And a simple heuristic for thinking of how to do testing based on any of these diagrams is, if there's something in the diagram, you probably have to test it. Not always. I mean, we can go back and look at this. Like, we're not testing the new user, for instance. The new user, though, isn't part of our product. Our product is over here. Our product is the application and the documentation. Our product is probably not the community, probably not the new users. But we could say, if the community is part of our product, that we could test the community in a way. We could see how responsive the community is to questions. What we would do with new users, though, is we might say, are there different kinds of new users? Do we have to go intentionally find different sorts of users? And so if I was going to do that, and if I thought of that, then I would probably do something like this. I would probably add to this more little examples of user heads on the diagram. I'm using my mouse to draw. You see, I'm not so good with my mouse drawing. And I might say, I have different kinds of users with different kinds of knowledge and background, and I'm going to recruit those users explicitly in order to get what I need. You see, so a basic heuristic is look at something on a diagram and say, do I need to test that? Do I need to vary that? Do I need to control that? Do I need to interact with it? Does anything on my diagram interact with each other? Do I have to test that? And then draw some little red line. I like to, when I'm doing this on a whiteboard, I like to use basically black and blue ink for the system. And then I'll use red ink to represent any test ideas that I want to talk about. And then I'll take a little picture of the whiteboard usually. Here's another real popular one. I bet a lot of you are testing something like this. Excuse me. You've got a front end and you got a back end. The front end is a web or a mobile facing thing that the user interacts with, but the back end involves a whole bunch of services, perhaps third-party services. Well, that poses a real challenge during development. We may not have these services available when we're trying to test the product early on. You know, we're all trying to shift left, right? We want to do early testing, right? Well, but maybe these third-party services aren't hooked in. Maybe they're not even available. Well, then can we mock them? If they're not mockable, can we interact with them using test data? I once had to test a system that interacted with a government website in Ireland that tracked bankruptcies. So we approached them and asked them what data was in their database so that we could put it into our system and then go and access the data in their system. And what they said was, we can't tell you that. You have to already know the data that's in our system. It's public data, but you have to already know what's in it in order to go find it. So I just tried typing some random names, random Irish names into this government website, and I wasn't getting anything. So I decided to write a tool that generated 300,000 Irish names based on a website that had baby names for Irish kids and another website that had family names for Irish people. And I just combined them and I got, hundreds of thousands of names. And then I picked 1,000 of those and I slammed them into this website. And again, I got no hits. So then I was forced to read the news. I went on Google News and searched for Irish businesses that had recently failed. And then I looked at the names in those news stories, and one by one, I typed the names in until I found one name that got a hit. We ended up using that one name as test data to check if our system could correctly talk to this Irish official public government website. That was terrible, but I'll bet that happens to people a lot where they're stuck, where they don't have the cooperation of these third-party services. And yet they still need to test whether their systems can interoperate. So it's frequently a problem. If I do automation in such a system, I am going to want to automate through the back end. I want to avoid GUI level automation as much as I can because it's so hard to maintain it. It's so hard to keep it running. And usually it just ends up being very shallow stuff. I'm going to do experiential testing instead through the front end. By experiential testing, I mean I will use the product like a real user as a human would. That's experiential testing. Some people call that manual testing. I think that's a bad word for it. I don't use the term manual testing, but I will say experiential testing. I will say attended testing, meaning a human was in the room. I will say exploratory testing, but you won't catch me saying manual testing until the developers start saying that they do manual development. I will not say that I do manual testing. Oh, Michael has just dropped another link into the chat room that relates to this. Thank you, Michael. I didn't know that you had done a thing on that. You did in August. Oh, okay. Boy, he's blogging and I don't even realize it. Okay, what's this situation? Look what we have here. We have one user and there's two arrows here. What could this mean? This looks like a laptop. This looks like a phone. And then we're going to a server and a data. So it seems like one user is using two devices. Well, this is emblematic of an important kind of functionality, which I call split platform functionality. Split platform means that the user might start a process with their phone and then transfer to a desktop machine or even a television or some other kind of embedded system. I should add a I should add an embedded system onto this, a television or something like that, because this happens to me a lot. Well, I'll mirror something that's on my phone and I'll put it up on the television. So this calls for something called split platform testing, where we divide scenarios and do some of it with the phone and then finish it, like fill out a form halfway, save it or something, go and log in with another device and see if we can finish it there. Sometimes you get some really interesting bugs doing that. Related to that is this. This is a bunch of people collaborating on one document, like an electronic whiteboard or something. And notice that they each have different devices. This person has a big screen, huge monitor. There's someone with a little laptop, a couple people with phones. And this thing here, I know it looks strange. It looks like a door handle. It's actually meant to indicate a telephone that has only audio capability. So if you were around in the 70s, you know what that looks like. So imagine you have someone just on audio with Zoom, say, and then these other people are on their tablets or telephone or smartphones. And then you got people with real computers, and they're all trying to watch a Zoom presentation like this, or they are interacting with each other as they do this. So we want real-time multi-user testing with lots of different devices. We want to see if the different devices play well together. Maybe they will not interact with each other in an effective way. Maybe the person with the big screen is going to be doing something and the people in the phones are not going to be able to see it because it'll be too big for their phone screens. Maybe the people with the phone screens are going to try to draw something on the phone screens, but it's going to be, it's going to look all messed up on the big screen. Maybe the person on audio is not going to be able to follow any of it. And then I try to think of a way to symbolize user privileges. Maybe I could have made little hats for people. I couldn't think about it. So I just wrote, what about user privileges? Users might have different levels of access while they're doing this stuff. Well, for instance, right now in this Zoom thing, I am a panelist. So that's different from being a participant. Well, that might cause some kind of trouble. So obviously the Zoom people better be testing between having lots of panelists and lots of participants, or just a few participants and a lot of panelists, or one participant and one panelist, or no panelists, all that kind of thing. And then us all using different devices. This is an embedded system. So you got your hardware, you have your firmware, you got your software, your data stuck inside that device. Imagine what you would say to this. Well, I hope it would be something like this. I hope you'd notice that the firmware is going to have to be updated at a certain point. So we need to do update testing on it. We need to do configuration testing because this hardware device can probably be configured in more than one way. Another thing that just occurred to me right now, so let me add something to this with my pen. And you know what? I'm going to try something. I'm going to use my graphics tablet here. Woo, so I can do good drawing. Okay. So another thing that just occurred to me is we have to consider, I'll do this. I'll make a spiky thing around this. It will be spiky. What does the spikes mean? I'll tell you what they mean. The spikes mean, oh, why did it do that? It just went away. Oh, that's PowerPoint for you. You can't trust PowerPoint. I tell you, PowerPoint, you have betrayed me. There we go. What I'm talking about is factory reset. If you have an embedded system, especially in the Internet of Things, and you put your personal data into it, and later on you want to sell it or throw it away, you need a way to wipe out all the data that's in that system. So we've got to test factory reset as well.
Hey, can that data thing get full, James? Can it fill up?
Oh, that's another good one. Okay. What happens when the data just starts growing and growing? The capacity is another thing that we need to think about. Really good point. You see how the visualization of these summaries triggers ideas? That idea was not one that I had, but as soon as he said it, it made me want to depict this in some kind of a diagram.
Plus, it also occurred to me, it's in the chat, but hey, where the heck are the interfaces for this thing? How does stuff get into it and out of it?
Oh, yeah, good point. So we probably needed to have in black, we needed to have some kind of buttons
or pipes.
Keys or tubes or pipes. We also have other devices that might be connected to it. So you can easily see how this can turn into something more complex. You're summarizing the product. I mean, the product has lots of features, presumably lots of code in it. No matter what we do with this diagram, our diagram is going to be far simpler than the product is. But by thinking visually, this is one way that we can get our brains to think about what the testing implications are. And you see I put a little storm cloud over here to remind myself that environmental testing might be important, not just testing in the rain, of course, but testing with heat, with humidity, with dusty environments, with our environments with poor internet connectivity, all that kind of thing. Here's another popular kind of application I'm sure you've seen. If you've ever worked with SAP applications or lots of e-commerce applications are like this. 1 zillion business forms. You go through screen after screen after screen, filling things out. You know about this if you've ever applied for an Indian visa, for instance, or for that matter, probably an American visa will be one of these applications where it takes forever to fill out the forms and you have to worry about timeouts and saving the forms and all this. Of course, whenever we see an application like this, our minds immediately turn to automation. Maybe these forms are regular enough and simple enough. Hopefully they're not too fancy so that we can do GUI level automation, or maybe there is a sub GUI kind of automation that we can do. We also need to think about different pathways through this, different scenarios, you might say. So this calls for scenario testing, where we imagine different kinds of users trying to do different kinds of things. And as we do this, remember, it's not just a functional issue. It's also a matter of data. And we've got to do this with different data as well. So I actually got to give you an example of this. Just the other day, I was trying to use an event management system for setting up my classes, and they let you apply for a special kind of payment system, but they asked for your social security number. And the problem is that I'm not doing this personally. It's my corporation that's doing it. So I'm going to use my corporate ID number instead of my personal social security number. But it didn't understand that. the system is only set up for personal, individual people to use it, they didn't think that a corporation would want to set up an event, which is a pretty big oversight, if you ask me. But there was no way to make this work for corporations. And when I contacted tech support, they said, oh, well, we're going to have to walk you through that by hand. We can set it up for you, but we have to do it behind the scenes. So what is that? That's somebody not thinking about a certain kind of user, but it's also somebody who's gone through the pictures, they've gone through the screens, but they didn't think about the different kinds of data, all the different kinds of data that would be needed in those different situations. All right, so what you just saw there is a bunch of different ways of summarizing, and Michael, that's what I wanted to show you. So so you've now seen all of the new stuff, Michael. You can think about it, and we can come back to that. So what I want to do now is come back to this narrative model, and let's go through this narrative model. Okay, here we go. This is a little application I have that zooms into complex diagrams. So we have this. I argue that all testing is like this. This is the story of all testing, all good testing. All testing has a context. The context may be murky, complex, it may change a lot. It's social and involves limitations. In that context, there are people who matter. We testers need to know who matters, which people matter, how do they matter? Because those are our clients. So what? What about them? Well, these people have requirements. They have things that they want. Some of those things they tell us about, and some of those things they don't tell us about, but they're still true. Development gives them what they want, but maybe they won't give them what they want. That's called product risk. The mission of testing is to serve our clients by understanding the requirements, examining the product, and evaluating the risk that the clients aren't getting what they want, that the people who matter will not like this product. So that is the business context of software testing. Virtually all software testing has this dynamic, this logic is what's driving almost all software testing. Now you see, I call this a narrative model. Why do I call it a narrative model? Because it's a model that helps us tell a story. It has the structure of a story built into it. You see that I've even written out the story. In this world, there are people who matter, who have things they want, and development gives it to them, but maybe they won't get it. In comes the testers to save the day. How do they do that? We have a strategy. Our strategy is a variety of ideas that guide our activities, that guide what we're actually going to do to test, that guide our activities that relate to test design, that is. Reasonably inexpensive yet effective actions, formal and informal, deliberative or spontaneous, for the purpose of performing tests. These actions include, everything down here is the structure of an individual activity wherein we perform some test. So let me say that at the center of this is you. The testers and anyone helping testers are at the center of this test activity, of any test activity. And with the testers is their skills, the skills you have. your tools that you have, the testability of the product, all of this allows things to go. Well, what things? Well, let's zoom back out again. You see how the arrows kind of go in clockwise fashion here? This is what we call the vortex. It's like a swirling whirlpool that kind of whirlpools in a clockwise direction. All of these things work together. It's not a hard sequence, but in general, it moves around, it swirls around in a clockwise way. Where we are learning, we make models of the product. Based on the models, we design our experiments. Our experiments take the form of test procedures that we then execute. The test procedures, let's just zoom in here. So we've got our models, okay? And we design our experiments. Here are our test procedures by which we configure, operate, observe, and evaluate the product. And that includes our tools, our coverage, which is what we look at, our oracles, which is how we know that there's a bug. It's an oracle. And then we actually perform the tests. We get our test results. We report our test results, and this updates the testing story. Our testing story is our current understanding of the testing that we are doing, the testing that we have done. It's our narrative of the testing as we understand it. And you can break that down actually into three things, three questions. How's the product doing? How do we know how the product is doing? In other words, what did we do to test? And then we can ask the question, was the testing any good? This is a 3-level test report. What are the bugs? How do we know those are the bugs? And what can we do to make the testing better, if anything? And then this continues, because when you know your testing story, then you can say, there's a problem with the testing story. There's a hole in my testing story. So you got to learn more, and you have to create more models, and you design experiments. Now, I want to address some things that might be confusing you, which is, notice I say models here. And you might say to yourself, but James, I write test cases. I don't make models. And I would say to you, you absolutely make models. If you write test cases, then you are making models, because every time you write a test case, you're doing that based on your understanding of the product. That is called a mental model. So I hope you go, oh, you don't just mean written models, explicit models. You also mean models that are just stuck in my head. And by model, well, I'm talking about a representation. I'm talking about something that is not the product, but it represents the product. So the ideas in your mind that represent your understanding of the product, those are models. The more you learn about the product, the better your models get inside your head. You can, of course, also write out models. You can make state models. You can make lists of features. If you just make a list of all the features or user stories, a set of user stories is a model of the product. Models can take infinite forms. Source code is a model of the product. So what I'm saying is that as you learn, your learning crystallizes ideas in your mind. And based on those ideas, you go, okay, I have an idea for a test. Now, your test strategy is guiding all this process, but more than just your test strategy in general, your very, very specific ideas and experiences cause you to design specific tests. I'm saying design experiments because every test is an experiment that you are running on the product. You have to have a way of doing that. That's what test procedures are. You might not write down your test procedures, but whether you write them down or not, they exist. To have a test procedure is simply to have a specific way of actually doing the test that you have in your head. That's a test procedure. Whether you write it down or not, they exist. And those specific ways involve looking at the product in some way, detecting bugs in it if they exist, using tools in some way. So it might be, there might be automation involved. So I hope you see that any activity that involves actually performing a test is going to have this basic structure, because you're going to start out that activity. Let's take performance testing, for instance. We begin performance testing with nothing. I got nothing. Someone tells me I have to do performance testing. What do? Well, I need to identify some part of the product that needs to be performance tested. So which part of the product might have performance problems in it? So that's a matter of risk. And that's another model. Risk is a model too. And then I say, well, what tools am I going to use? I might have a performance analysis tool. I might have a specialized performance testing tool, or I might just be using the product and I have a little stopwatch that tells how much time it takes to get through a process or for a certain report to be created. And then as I do this, I get better and better at performance testing. I get more refined at it. And then I can do regression performance testing, perhaps with my partially or fully automated checks. So that's performance testing, but also you can say this about any other kind of testing, boundary testing, testing a story. You can apply this to BDD, all this. So these are the elements that if, excuse me, if somebody stops me while I'm testing and says, why did you just press that button right there? Why did you just save that file? Why did you just look at that menu? I can answer. Here, I'll give you an example. I actually saw somebody do this once, so I will give you an example. I'm going to bring up a little product here. I will do, what will I do? I'll do this. I'm going to bring up Zotero. No, I'll do Microsoft Paint. That's a better one. Okay, so I'm gonna load Paint here. Okay, here's Microsoft Paint. Okay, so I once saw somebody do basically this. Okay, I was watching this person over her shoulder, and I saw her do this. She had this application, and she was just doing this. Just moving the mouse. And then going over to the next thing and just opening things like that. Not doing anything, just opening them. So I said to her, what are you doing? And she said, I don't know. That was her answer. And I realized at that point that she was probably overstressed, because standing behind her was me, plus her boss, plus the man who owned the business that she worked for, plus a representative from Microsoft who had just hired this test lab and was touring the test lab to see how people did their testing. So it's probably a lot of pressure on this poor lady who was, we were watching as she did her testing. So the other guys just stared at what she was doing. And I actually asked, what are you doing? And she said, I don't know. Well, later on, we decided to let her be. But later on, I went back to her and gave her a frame that she should have said. But I think she was too kind of frazzled to say it. But I think she knew it. I said, this is what you should have answered to me. You should have said, James, I am familiarizing myself with this product because in order to test any product systematically, I must make myself aware of its various features and capabilities. Therefore, I am touring the user interface as a necessary prerequisite to systematic, high-value software testing. Do you see that story connects what that tester was doing to why we are in business, to business value, in a way that the people listening could very easily have understood? But when she said, I don't know, it made it sound like she's just wasting time. When you can't frame your testing, you sound like a child rather than an adult professional tester. And you run a risk of people thinking you don't know what you're doing. I think that tester I talked to knew exactly what she was doing, and she just hadn't practiced explaining it. So when she had to explain under that pressure, nothing happened. She just shut down. If you practice your test framing, you start sounding like a testing expert. Sound like somebody that the rest of us should support and believe in. That's how important framing is. So this narrative model that you see here is kind of my cheat sheet. Now I use several different narrative models. This is my favorite one out of the various different models that I use. But I have different models that emphasize different kinds of things. So depending on my mood or depending on the situation, I will focus on one kind of dynamic or another. What this helps me do is tell the story that anything I do in testing is part of a learning process. I am not merely running test cases. I'm not merely writing test cases. As a tester, I am constantly learning and studying and applying my wits to the product to find bugs quickly. I am doing a scientific activity. I call this experiments because I'm just like a scientist running experiments, except I'm running the experiments on a product instead of on nature. I use fancy words like mental models because when I use words like that, people get the impression that I know what I'm doing, that I'm an expert, and they start believing my story. You have to know how to use these words correctly. You can't just spout nonsense. But I'm a big fan of technically specific, philosophically grounded, scientifically grounded vocabulary that allows me to speak in clinical terms about software testing. And then people say, oh, well, maybe even if I don't understand your explanation, I should just believe you and go along with you on that. And I say, thank you. Okay. I'm not trying to be hard to understand, But just as a doctor, when the doctor speaks like an expert medical doctor, that doctor will use technically specific Latin terms for things and then translate them for you. Similarly, that's what any expert has to do if they want to convey the impression that they are experts. All right, so let me go down here now, past all the summarizing stuff, and talk about a particular case in the last minutes that I have available here. Also, I wonder, is there any questions or anything? You know what? Nobody has asked questions. I'm looking in the chat room. I don't see any questions there. Of course, you can unmute if you can unmute yourself. I don't know if people can unmute themselves, but be my guest if you wanted to. If you wanted to ask a question at this point before I go through this examples, anybody got anything they want to ask or tell me?
It's not more a question, it's more like an add-on what you're saying. It's also what you're saying with the strategy and knowing what you're doing also help us sometimes to get off those bad habits of just doing test cases when the company only asks you, you have to do all those test cases to give you the tools to say why. If they are necessary, I have to know what I'm doing to using my time in a more efficient way to add value to the product, not just running a list of greens and saying, no, everything passed, so it's okay. So that's just like an add-on to that.
Well, what do you say, Eugenio, to people who say, hey, look, I write test cases. My team is happy with that. Management's happy with that. Nobody asks me anything. I'm never asked about my test strategy. I'm just asked if my test cases are finished. So why do I need to care about any of this stuff?
Because doing test cases is only an activity of testing. You're not doing real testing. You're just making
but the people who pay me and the people who do my performance review, all they care about is test cases. That's what they care about. So if I do test cases, I'm fine. Why should I worry?
Well, because at the end, if I suppose you're gonna get bored just doing that. At the end, we are here to investigate, doing more, expand. Our curiosity is one of the things that we have to be part of. One of the mantras that we have to do here in testing. So if you are okay with that, well, I think you're gonna get bored at the end. Doing the same thing over and over again.
So you're predicting that I won't like it.
Yeah.
All right, well, that's great. So as long as I keep liking it, then I can just continue to be this way and everything's fine then.
Well, supposing one point, if well, you're probably liking it, but the other around, it's probably, and if you continue, if that's the strategy of your company, I suppose in one point it's not going to work. It's going to fail.
Why wouldn't it work? What would make it not work? I'm writing good test cases, right?
How do you value that there are good test cases? Because there are
because we don't have any bugs that anyone's finding in the field. So they must be good test cases.
But they add value. Well, that test cases pass, and
well, I guess they do. I mean, they pay me to write them. They seem happy that I write. They keep asking, how many test cases do you have? And I go, well, I've got like 3,000 test cases. And they go, wow, that sounds like a big number. And I go, yeah, would you like me to write another 1,000? And they go, yes, please. And that seems like whenever my number of test cases goes up, they're very happy. Well, what I'm trying to probe for, Eugenio, is whether you're aware of a particular counter argument that you might make in this situation, which is, if everyone is satisfied with you just writing test cases and never explaining your test strategy, that can be fine until that changes. What if there's a problem? And what if somebody says, uh-oh, there's a big problem in the field. Why do we have this problem? Testing, tester, explain. Why didn't you find this bug? And you go, I wrote test cases. And they go, well, did you write the right test cases? And you go, maybe. And they say, well, how did you decide on the test cases? And suddenly you have to explain your test strategy. You never had to explain it before, but suddenly there's a problem. It's kind of like, you might, no one might investigate you as a driver of a vehicle until you have an accident with another car. And then suddenly they're looking at dash cam videos, they're looking at CCTV, they're downloading the black box to your vehicle to see if you routinely were speeding. Suddenly they put you under a spotlight. And then you better look good under that spotlight. I mean, this is the big reason why I actually, believe it or not, don't cheat on my taxes, because I never want to have the experience of the IRS coming to me and saying,
why?
hey, we want to look at all of your tax forms and look really closely at all your taxes. Do you mind? And I always want the answer to be, sure, look at them. Everything's correct. I'm not running a scam. I paid my taxes. Because otherwise I'm going to get a heart attack, and I don't want a heart attack. So, and I can't afford to hire a lawyer that's going to get me off, and I can't afford to bribe people that I would need to bribe. So I'm going to have to actually get by following the law. So I have, for 22 years, I've had an accountant who is very annoyingly honest. And I feel good about that, because I'm pretty confident that my tax forms are correctly filled out. And I just try to, not think too much about how much taxes I'm paying. I have this sinking feeling that lots of other small businessmen are not paying their fair share of taxes, but I try not to think about that too much. I just try to say, well, look, this is what I do for my peace of mind. So I'm not being scrutinized, but I'm ready to be scrutinized in this way. So even when my clients don't ask me detailed questions about, why did you do that testing? Why did you build those test cases instead of those test cases? What is your test strategy? Because I'm always ready to explain it. I am always ready in case the people change or the situation changes. And one reason why I am this way, Eugenio, because years ago in 1993, we got a new boss, a new QA director at Borland International, where I worked. And the first thing this guy did is he interviewed the development team for all of our products. And he came back to the five test managers that worked for him. And he said, I got some interesting feedback from the development managers. And we were pretty confident, because we had a good relationship with these development managers and the development teams. We worked really closely with them. We liked them. They liked us. We had no friction between them. But here's what the guy said. He said, the developers have no idea what you guys do. They told me, do we like the testers? We don't know, because we don't know what they do. They just shrugged. So the test managers were kind of shocked, because we're like, hey, we thought we were friends, guys. We work together all the time. But then we thought about it, and we realized the reason why the developers couldn't tell anything to our new boss about how good we were at testing is we never told them how we did our testing. And the reason we didn't tell them is they weren't interested. So we realized, you know what? Even if you're not interested, we need to educate you to some reasonable degree on what we are doing. We need to share our test strategies with you. You need to comment on them. So we realized that we were actually putting ourselves at risk professionally by allowing the development teams to not think about testing. Now, as part of that, I spoke to a developer in the British Virgin Islands who I'd been working with for a couple of years, but I'd never met him. He was always in the British Virgin Islands. So I was going over my test strategy with him. And I told him how I was testing a certain part of his performance analysis tool that we were selling. And he said, "Oh, James, I've always wondered, why don't you do more testing in this particular part of the product?" And I said, "Well, there's nothing there to test. That's why that doesn't do anything." And he said, "No, it does a whole lot of things. Didn't you know that?" And I'm like, "What? No, I didn't know that." So it turns out that for 2 years, this guy had worried about the poor quality of the test strategy, and he never told me that because he didn't want to offend me by complaining about my test strategy. So he never asked me about it. He just noticed that we weren't finding many bugs in this really complicated area that he expected there to be a lot of bugs. I never asked him where he thought the risk areas would be. I should have asked him. I never did. I never told him what we were doing to test it until we decided, okay, time to share our test strategies and tell our story about testing to all the development teams and get them to hear it and get them to comment on it if they have any comments. Then we started getting this great information from the developers about how we could do better testing based on their internal knowledge of where the risks were and where the complexity was. So that's why I'm so strong about this stuff. I never want to worry when someone says, "Why didn't you find that bug?" I want to just say, "I'll tell you why I didn't find the bug," but I'm not embarrassed by what I did. I know what I did. I made reasonable decisions. Maybe I made some mistakes, but I was not negligent. And I know I'm not negligent because I know my test strategy. I explain my test strategy. I get my test strategy reviewed so that it's not just my thing, but it becomes our thing. But that's a skill. It's a skill set to talk about test strategy and to explain how it connects to the value of the business. Now, in the last few minutes here, thank you for engaging me, Eugenio. You're great.
Thank you, James.
Now, in the last few minutes, I just want to show you this little example. This is a product called Decide Right. It's a product from the mid-90s. It's actually a product that it was one of the first products I ever used in a testing class to demonstrate testing. Because it's a nice, simple thing, but it's just complex enough to be challenging. It was sold at that time in a box because all software was sold in a physical box in those days. And the front of the box looked like this: Decide Right, confidently make the best decision every time. It's a product that helps you make decisions. On the back, it listed some of the features. Now, I handed this box to my younger brother when he was just starting out being a tester. And I challenged him to come up with a way of testing this thing, a good way of testing it in 15 minutes. I gave him 15 minutes, something like that, real short amount of time. And he was stuck for the first 14 minutes. But then he realized something in the 15th minute, right at the last moment. He realized that the back of the product box was a summary of every important thing that the product did. So he could come up with a strategy really easily by just saying, maybe I'll just test every major thing that this product does. I'll do some testing with easily lay out the decision, some testing with drag and drop, some testing with drive consensus, some testing with justify and communicate. There are these little pictures of screens. I'll test these screens. So he had this insight that the box itself was kind of telling him where he should be focusing. And that's a key insight in summarization. You can look at the descriptions that people, the capsule descriptions that people make of products, and that can often guide you in knowing where to focus and where to test. But to go into a little more detail, this is what the product does. You establish what you want to choose. Like, I want to buy a certain car. You establish what kind of variables matter to you. And then you rate how important each of the variables are. And then you rate the status of each of those variables. And then the product calculates what your decision should be based on simple mathematics. That's what it is. So it's that kind of thing. So if we go back up here, see this? I can relate this diagram to that product. Decide Right has a problem, which is it's hard to use. It's easy to accidentally misuse it. So we probably have to do usability testing with this. Another thing is it's like this. Input, super complicated algorithm that you don't understand, miraculous important output. So this is a tool that says, this is the right decision, but do you understand why it's the right decision? You need to understand why it's the right decision if you are going to productively use a tool like this. So both of these diagrams relate directly to this thing here. This is my summary of the product, an application to help people and teams of people make important decisions. What are the key risks that I see? Well, obviously, it may tell you to do the stupid things. People will not use it correctly, and then they'll get the wrong decisions, and they won't know that it's because they put in the wrong data. It says it can compare scenarios. Well, maybe it will compare them incorrectly. Maybe some decisions are very complex and it won't be able to handle those realistic, complex decisions. So based on that, I dreamed up some test activities. These are my ideas that will guide my test design. I need to understand this underlying algorithm, simulate the algorithm in the spreadsheet. So I think I'm going to try to duplicate Decide Right in a spreadsheet, which turned out to be really easy, much easier than I thought it would be. I got to test each of the functions just to see if it can do what it says it can do. But I also need to do a lot of stuff with the complexity of data. So I'm going to generate large numbers of decision scenarios. This is the actual test strategy that I wrote as a document. You see, I have a brief description of the product, and then I have made little paragraphs with bullet lists saying, I'm going to do this kind of testing and this kind of testing and this kind of testing. So there it is. That's my strategy. Now, if I do the testing according to this strategy becomes a tool to help me frame the testing, because I can say why I'm doing the testing, what I'm doing, why I'm doing it, how it relates to business value. Now, I actually have the product here running on Windows 95 in a virtual machine. This is the actual product. And I don't know if you can see it, if Zoom is going to let you see it. Eugenio, can you see my screen right now?
Yeah, I can see it.
Oh, I'm very glad to hear that. Let me show you something, because this is kind of fun. One of the things that I did when I was figuring out how to test this is I thought maybe there's some simple way that I can do stress testing on this. So I just typed some things, and then I said, oh, new options. Well, why don't I type an option A, B, C, D. And then why don't I just do, why don't I do Control ACVV, ACVV, ACVV. So I'm just doubling the amount of items in here. So I've just created, I don't know, hundreds of items here. And then what if I just say next? And then what if I do the same thing here? What if I say XYZ? And what if I do the same thing? ACVV, Control A, Control C, Control V, Control V, Control A, Control C, Control V, Control V. And I keep doing that to double the amount of input over and over again. So I've got lots and lots of things. And then I just say, click next here. Oh, look at that. Oh, it just generated a huge number of combinations. And now I'm, can I use tab to go over here? I can use tab. What I'm trying to do is get it into a loop. I might not have created enough items. Maybe I should have created like 10,000 items. And I didn't create enough. When you create enough, it starts going a little bit crazy. Now it's asking me to rate all these things, which kind of creates a usability problem, doesn't it? If you have a lot of factors and a lot of things and you have to rate every one of these things, this could take you a long time to do. And then once you do that, now, is it usable? So I think I didn't put enough items in, but I found out that if you put 10,000 items in, it crashes, it gets garbage all over the screen. There's all kinds of trouble. So that's just a little fun little testing thing I did. And it relates, and you could say, James, what's your framing of that? My framing is that I do that to do inexpensive, quick stress testing. I'm doing stress testing to discover how reliable the product is when you do complex things with it. I can quickly find out if it is unreliable using a kind of testing like that. And that provides business value because unreliability is a problem for our clients. We don't want our clients experiencing a flaky product. So there, I've just framed that. All right, I'm out of time. Thank you for visiting us here, and I hope you got something useful out of this. I would love to see if somebody practices with some of these little diagrams. Maybe make your own diagrams, share them with me. I'm trying to make a big library of summary diagrams that I can put in like a big sort of book of test strategy ideas. So, so if anyone's got anything they'd like to share. Also, Shiva, you have your hand up. Did you want to say something, or are you saying you have some diagrams?
James, I have a question.
Okay.
With regarding the test strategy, okay, you have mentioned in the initial slides that, like, how to differentiate, like, with a bad strategy and a good strategy, right? You mentioned that, you can do a good looking framework with a bad strategy. And you also suggested that we do not follow such kind of, implementation. How we can understand that it is a bad strategy and having a good framework, a good looking framing?
Well, the main thing is by using risk. It's risk that saves you from having a bad strategy. A bad strategy is one that is not aimed at risk. It's causing you to spend your time on things that don't matter. That's what a bad strategy would be. A strategy that guides you to build the wrong tests at the wrong time is a bad strategy. A strategy that causes you to build tests that are too expensive is also a bad strategy. So risk is part of the answer to that question. When you focus on risk and are able to say, this area is more important to test than that area, then you're going to automatically be along the way to a much better strategy. But there's another problem too. And that is, you might not have the right knowledge. So there's one problem, for instance, people often get into where they don't know very much about programming. So when they're thinking of how to use automation to test something, They think of only expensive ideas and expensive tools because they don't know about inexpensive tools. They don't know about easy automation approaches. So another way that you can do better test strategy is have more knowledge about the technology you're testing, more knowledge about the kinds of tools or ability to create your own tools to help you test. And that will also enable you to have a better set of ideas to guide your test design. Now, if you don't personally have a lot of knowledge about the product or a lot of knowledge about tools, you should make friends with people who do have that knowledge and collaborate with them. So in a modern, agile, DevOps-y kind of project, you're supposed to be getting the developers to help you anyway. So the developers might be able to think of a tool that's a nice, convenient tool that you could use that might be better than using Selenium, for instance.
Thanks, James.
All right, well, my time is up. So I will let you go. Thanks again for coming to my event. And I hope that you found this instructive.
Yes, thank you, James.
All right. Bye, Eugenio. Nice to meet you.
Nice to meet you too. Bye.